I'm Patty DeMuyt. I am a member of the architectural team at USG. Today's CEU is entitled Optimizing the Human Experience. The front end of this presentation is designed to draw a distinction between the aesthetic of a space and the experience we have within that space. These are two different design directives. Aesthetics of a space. This is a physical construction, a visual upon which people and organizations write their stories. Certainly, this can be done in isolation. Experience within a space. Crafting an experience requires building upon that aesthetic stage. We seamlessly bring together a spatial design with the architectural elements of light, material, and sound, inviting new ways to work, live, and play within a space. In today's program, we will examine what it means to optimize design and how this plays into crafting the human experience within a space. This presentation outlines the acoustical challenges in 4 major markets: the workplace, healthcare, hospitality, and education. We will walk you through some of the fundamentals of acoustics that will help you evaluate available solutions in light of the acoustical challenges in each market. And finally, we are going to talk about the built environment as a platform for wellness. At the onset of creating a design, the architect begins the process with a purpose. Optimized design is the process of creating the best design relative to a set of criteria that has been set as priorities. Certainly, purposeful design can result in great architecture. And in this first example, it is said to have advanced humanity. Thank heavens for Eero Saarinen, the Finnish-American architect that was a late addition to the jury panel to determine the design of the Sydney Opera House. Unimpressed with the designs, he went back to the designs that were rejected by his fellow judges and came upon the now iconic design by Jorn Utzon. Jorn's design was inspired by peeling an orange. There are 14 outer shelves in the design, and if you were to assemble them, they would form a perfect sphere. Utzon wanted to create a building in which the facade is not the same from all angles. By artfully placing these slices, he achieved that. Jorn collaborated with engineer Ove Arup. Their total design approach of gathering all resources in one place where architects collaborate with other professionals to realize their design revolutionized building design within their lifetime and influenced how buildings are made today. This duo and their team spent 4 years figuring out the shell structure in precast concrete. The building was not complete for 17 years. Utzon made a building well ahead of his time, far ahead of available technology, but it resulted in a building that changed the image of an entire country. The next architect we are going to discuss is Louis Sullivan. He was an American architect that identified with the aesthetics of early skyscraper design. A quick look at any tall building built during this time from about 1890 to 1930, and you'll see Sullivan's influence on American architecture. Sullivan's style has become known as the tripartite design, 3 definitive exterior patterns for the 3 functions of a multi-use skyscraper, with offices rising from commercial space and topped with a ventilating attic space. Louis Sullivan believed that the exterior of a building should reflect its interior functions. Sullivan coined the phrase, "form follows function," and it became the touchstone for many architects. This means that the purpose of a building should be the starting point for its design. As a young architect, Frank Lloyd Wright worked with Sullivan and extended the teachings of his mentor by changing the phrase, "form and function should be as one, joined in spiritual union." This next architect is a personal favorite of mine. I had the privilege of meeting her before she passed. When you met her, you immediately knew that she was all about wellness. She wanted people to feel good in the spaces that she created. Zaha's professor described her at graduation as a planet in her own orbit. She was the inventor of 89 degrees. Nothing was ever 90 degrees. She had little use for details. The way she drew a staircase, you would smash your head against the ceiling. She couldn't care about the tiny details. Her mind was on the broader pictures. She knew she could fix the details later. This Iraqi-British architect became synonymous with intensely futuristic architecture, characterized by curving facades, sharp angles, and severe material, such as concrete and steel. Zaha's designs mystified. She took the strongest materials in the world and manipulated them to form objects that appear soft and sturdy at the same time. All three of the architects achieved optimized design. In fact, as we look at these pictures, they are visually spectacular. But what is missing? The human experience. We have examined the visual experience. What makes the human experience within a space? The experience in the space is everything you can see, but in addition, what we smell, touch, taste, and hear all affect the way you feel in a space. In an office environment, it is your chair, it is your desk, it's the art on the walls, the temperature, it is the communal tables, and the lunches you eat from them. It's the noise from the street outside your window and the loud talker in the next cubicle. At the top of the list for complaints in today's spaces is poor acoustics. In this next section, we are going to take a look at the challenges specific to 4 markets: workplace, healthcare, hospitality, and education. Welcome to a typical commercial building. Come with me as we enter the lobby. This space incorporates the most common materials specified in commercial construction today: glass, stone, wood, and drywall. Just like a reverberation chamber, there are hard surfaces on the floors, walls, and ceilings. If we were to let sound out in these spaces, you would hear the sound bouncing off of these hard surfaces. These materials, however, are selected not just for their aesthetics, but for their durability and their cleanability. So in all of the markets we are going to discuss, there are spaces that are designed to hold groups of people. What happens when a lot of people congregate? It is noisy. The challenge with hard surfaces is that these materials create echoing and reverberation. The first market that we are going to talk about is the workplace. In order to understand today's acoustical challenges, we have to go back and look at the changes that have occurred in the past decade when the millennials entered the workplace with expectations of a work style that differs from their predecessors. Architects were challenged to design spaces to support the collaboration which fosters the creativity and engagement that organizations need to innovate. To achieve this, architects and designers started to look at the workplace like an ecosystem. By rearranging the placement of the individual, private, and collaborative spaces, you can gradually move from a traditional to a transitional to a progressive space plan. SCIP, A traditional layout. This plan is largely made up of resident workstations, 65% with private offices. The collaborative spaces are placed along the perimeter and clustered together away from work areas. Furniture features privacy options like high panels. Jump, a transitional layout. This plan includes an open space broken up into more team-oriented vignettes with adjacent collaborative spaces. All private offices are shared. Free address space or hoteling is introduced. Furniture is now lounge-oriented. Leap, a progressive layout. Only 10% of the space is owned. The remaining space is shared by all users. Team spaces are flanked by private and collaborative spaces, giving workers a choice as to how they want to work. In this plan, collaborative spaces are equally balanced with individual spaces. According to the Wall Street Journal, more than half of the companies in the United States have moved to an open office plan, a great environment for collaboration. The liability, privacy doesn't exist. Here lies the acoustical challenge in the workplace. In fact, 69% of employees are dissatisfied with the noise levels at their primary workplace. And according to the Center for Built Environment, over 60% of those employees working in an open plan office claim that noise interferes with their ability to get their job done. Research goes on to say that 53% of employees are disturbed by others when trying to focus, because 77% of employees prefer quiet when they need to focus. Sound is negatively affecting an employee's experience at work. Why is that? Voices in excess of 55 decibels cause measurable stress, roughly the sound of a loud phone call. So what do employees do to cope? 42% use makeshift solutions to block out distractions. That would be earphones, quiet areas like huddle rooms in this picture. The average American retires at age 66 today. It is not uncommon to have 5 generations coexisting in the workplace, from the traditionalist who has aspired to a corner office to the millennial who couldn't care less where they sit. How is the open office plan affecting our behavior? In 2018, Harvard paper examined the impact of the open workplace specific to communication and productivity. These professors studied an office setting before and after an open workplace renovation in Fortune 500 companies. They found out that staffers spent 72% less time interacting in person and 56% more time sending emails. Face-to-face communication declined from 5.8 hours a day to 1.7% hours a day. Executives reported that productivity declined with the lack of face-to-face communication. The Center for the Built Environment's research is consistent in reporting that over 60% of employees in an open plan office think that noise interferes with their ability to get their job done. America's hospitals are going through a design renaissance as they focus on the patient experience. In this market, I think it's important that we talk about Canadian architect Ty Farrow, who developed the cause health model. This theory says the best test for whether design is effective is whether the built environment allows people to thrive mentally and physically. This concept has changed design expectations. The occupant's physical and mental well-being is now a high-priority design directive for architects and designers. It requires looking at the patient experience from the sound standpoint. Designers are challenged to reduce noise levels but enhance sounds that make the occupants feel better. Researchers concluded that the OR noise can cause a decrease in auditory processing, particularly in the presence of music. In other words, it's not in your best interest to have your heart surgeon listening to Led Zeppelin while you're operating. Unwanted noise is a major problem in healthcare facilities. Johns Hopkins, one of the top hospitals in the country, reports that sound levels throughout the hospitals average 20 decibels above the World Health Organization's recommendations. Patient room sound should not exceed 30 decibels, and yet background levels average between 40 and 70 decibels. Areas outside patient room average levels of 65 to 85 decibels. In fact, it was found that typical conversations were measured at 45 to 50 decibels, which signals that the patient care teams were finding it difficult to communicate without raising their voices. Research shows that high noise levels negatively affect patient and staff well-being and slow the process of healing for the patient, leading to higher incidence of rehospitalization. Again, the challenge of an architect today is to reduce the noise while still allowing sounds that make the patient feel better. Certain types of music help reduce anxiety and stress amongst patients. Good acoustic design results in better morale for both patients as well as the providers. A condition key to healing. The lobby is your first impression of a hotel interior. It should be nice, but acoustical consideration should help make the guests feel comfortable. Sound is a critical element to the success of a hospitality venue. Along with sight, it counts for 99% of all brand communication. Sound serves as an emotional connection to customers, creating positive memories with a hotel or restaurant. There is a range of acoustic issues in restaurants, bars, and lobbies. Background noise, such as music, kitchen cutlery, dishes, and talking. Hard surfaces, the floors, the ceilings, and the walls. Hard, non-absorbing furniture, glass, AV equipment, HVAC. Soundproofing with different levels of absorption are important considerations in addressing these key challenges. Noise and its impact on food and drink was studied at Oxford. Both background noise and loud music can impair our ability to taste. The average background noise level for restaurants open to hotel lobbies is around 85 decibels, which is not dangerous but completely unpleasant, and close to a harmful threshold of 125 decibels. Reducing noise in the lobbies, open bars, and banquet halls greatly improves the overall impression and experience in hospitality spaces. Signal-to-noise ratio is a metric used in evaluating good acoustics in the classroom. The measurement is used to compare the level of sound attributed to the signal, the teacher, to the level of the background noise, student interaction. The desired outcome is to ensure that the signal of interest, the teacher's voice, is louder than the background noise, pupils in the classroom. Signal-to-noise ratio plays an important role in learning. Studies have shown that kids are less able than adults to ignore irrelevant sounds and thus are more susceptible to sound-induced disruption. Poor acoustic lessens their ability to concentrate in learning environments, leading to cognitive fatigue and anxiety, resulting in poor learning outcomes. Emerging technologies help designers plan for a sound experience. auralization is a procedure designed to model and simulate the experience of acoustics rendered in a virtualized space. In this space, auralization can help us hear the sound difference with the placement of acoustical treatment overhead. In this case, baffles can improve the sound control in this restaurant. There are also mobile apps like I Hear You to help people find locations with noise levels that suit your needs. If you're looking for a quiet eatery, I Hear You's GPS will help you find it. Now that we have talked about the acoustic challenges, let's walk through some fundamentals of architectural acoustics. How does an architect manage sound within a space? It basically boils down to three approaches: absorb it, block it, or cover it up. So if we're looking to cover sound masking can be done through an electronic noise system using white noise to create enough of a background hum to dull the frequency of speech. The second option is to block sound. Architects turn to single-rated testing systems that are used to evaluate a material's ability to absorb sound. STC, Sound Transmission Class, a measurement of how well a material blocks airborne sound through a partition. CAC, Ceiling Attenuation Class, evaluating how well a material blocks the transmission of sound through the ceiling when a partition is built up to the ceiling and not to the deck, allowing sound to travel from one space to another. IIC, Impact Insulation Class. This measurement examines how well a building's floor reduces impact sounds such as footsteps. While sound isolation and room acoustics are interrelated, for this presentation, we will focus on room acoustic design as it relates to acoustic challenges previously described. Room acoustic design deals with acoustic environments within a space and how sound energy interacts with the interior surfaces and elements in a room. Sabins is a unit of sound measurement. It measures how well 1 square foot of any surface texture in a room is able to absorb sound. All surfaces are ranked from 0 to 1 for their ability to absorb sound. 0 indicates a complete lack of absorption, and a 1 means perfect absorption. This absorption coefficient is then used to assign an NRC value to any surface material. The Sabin count is simply the sum total of the absorption coefficients in a room. Stronger NRC values will deliver stronger Sabin counts, which in turn signals slower reflections, lower background noise, and a more controlled acoustic environment. As sound energy travels in a space, it is reflected or absorbed as it interacts with all the elements in the room: the wall, the floor, the ceiling, the surfaces, furniture, and other elements in the room, including humans. Reverberation is the persistence of sound energy within a space due to ongoing reflections. Reverberation is a function of room size and the amount of sound absorptive material present in the room. When interior surfaces are dominated by hard, sound reflective materials, sound energy will tend to persist and build up within a space. This results in uncomfortable, noisy environments. Sound absorptive material will reduce reverberation, limit the buildup of noise, and improve acoustic comfort. Noise due to excessive reverberation is at the heart of all acoustical challenges described earlier in this presentation. A common measurement of reverberation is reverberation time, which is the time it takes for sound levels to decrease by 60 decibels within a space. Reverberation time is an important room acoustic design parameter for acousticians. Various spaces will have a target range of appropriate reverberation times depending on the size and the use of the space. Consultation with an acoustic design professional is recommended for any space or project in which acoustics is identified as a priority to pinpoint ideal reverberation times specific to the function in a space. Excessive reverberation time can have deleterious effects on human experiences. Noisy, reverberant office environments give way to more distractions, stress, increased error rates, and a reduction in productivity. Excessive reverberation in core learning spaces interferes with communication and a student's ability to focus and learn. In healthcare facilities, excessive reverberation and noise can increase stress, susceptibility to infection, and healing time. Too much reverberation and noise in restaurants can negatively impact social interaction, reduce acoustic comfort, and actually diminish flavor perception. Solutions. There are many ways to pack as much acoustical material in a space as possible. Here we see a traditional grid system. It is most often a 2x2 or 2x4 module. Ceiling panels allow access, and new panels can be swapped out as needed when damaged. It performs well reducing reverberation, and it has a range of textures and patterns to choose from. Modern designers are not too fond of the exposed grid look. A more advanced version of the grid ceiling is the integrated ceiling system. This allows access and provides good reverberation control just like a standard grid, and in addition, these ceilings offer a cleaner, more organized appearance. Utility channels are used to hold the lighting, diffusers, speakers, and sprinkler heads, leaving open areas of clean, large format panels. The aesthetic improvements are noticeable, however, you still see an exposed suspension grid. Custom perf patterns like pixels is a newer addition to the product mix. This type of system utilizes holes in the surface of the metal that allows sound to pass through. An acoustical scrim is laminated to the back, or an insulation pad rests on the back of the panels for sound absorption. Wood is a warm and beautiful material. Wood panels with perforations or micro-perforations is a product option coupled with an absorptive backer material to control sound. Acoustical baffles are another method of controlling noise by redirecting and absorbing sound energy. Baffles made of various absorptive materials or non-absorptive baffles with acoustical materials behind. The ceiling choice becomes almost a sculpture. Felt can also be used to control noise. Here are some interesting examples. Baffles of all sorts of shapes and patterns can be created with felt. There are a great many styles for acoustical wall treatments made from materials such as metal, wood, and fabric. This product is used both to reduce reverberation as well as decorate the space. Acoustical plaster has been around for 15 or 20 years. It works a lot like conventional plaster. It is a liquid coating that is hand trowel applied to achieve a smooth finish. It differs from plaster in that its substrate is an absorptive pad material, most often fiberglass. This trowel-applied finish is acoustically transparent and allows much of the sound energy and noise to pass through the surface where it is absorbed by the backer panel. This type of system uses a fiberglass base mat, which is adhered to a substrate like drywall or masonry, and then it is covered with a hand-applied acoustical plaster base coat. Once the base coat has dried overnight, a finish coat is hand troweled over that surface. This product is a complicated process with a lengthy installation. This high lobby ceiling was designed with acoustical plaster, which requires the construction of a dance floor for the plasters. According to the architect on the project, it pretty much prevented anyone from doing any work below it for almost a month. The newest technology, monolithic acoustical drywall, allows the architect to keep the monolithic look of plaster, but it is a simpler, less expensive process. The directives in developing this product was to keep the process simple. It mirrors the installation of regular drywall with an added technology. This product gives the architect a clean aesthetic with the acoustical performance at a reasonable cost. It also was designed to be quickly adopted by installers. The process has 5 steps. Like the installation of regular drywall, you have a suspension system. The backer panel sits like a lay-in ceiling atop the grid. The engineered gypsum panel is then screwed into the grid. You fill, tape, and sand normally. The final step is a spray application of an acoustically transparent spray. The system works like this. Sound goes through the perforations on the board and is caught in the backer panel. The spray finish covers those perforations and is acoustically transparent to allow the sound to rise up through the board's perforations. And the end result is it looks just like drywall. In fact, this product can be strategically placed next to regular drywall. This keeps cost in check. The spray over both monolithic acoustical drywall and regular drywall keeps a seamless aesthetic. The built environment, a platform for wellness. The drivers of business value have evolved over the last 40 years. In the 1970s, the U.S. was driven by capital investment and manufacturing. Today, the foundation of the U.S. economy is services, which are driven by intellectual capital rather than tangible assets. If more than 80% of the company's value is based on its people, shouldn't buildings be designed to optimize their performance and wellness? High-performance buildings, first and foremost, are designed to enhance the occupant experience. This structure fosters productivity, comfort, and health, all the while reducing energy use and environmental impact. Key definers of a high-performance building: air quality, thermal comfort, lighting, active design, biophilia, and acoustics. While there is no authoritative checklist that defines a high-performance building, requirements are often communicated through high-performance rating systems like LEED and the WELL Building Standard. Paris, home to the city's Philharmonic Concert Hall, was designed by architect Jean Nouvel. After renovating 26 areas in the building, Nouvel boycotted the building's opening, which he claimed was too early, for the unfinished building had not had a chance to test the acoustics of its centerpiece, the concert hall. For Nouvel to take such a strong stance on the acoustics of a concert hall, of course, is understandable. As architecturally great as the hall might be, it is automatically discounted if it doesn't perform. But getting acoustics right in a range of other applications, from hospitals to classrooms, is just as important. Making acoustics a design imperative aids in helping people to thrive mentally and physically in a space. 76% of workers report that they are struggling with their well-being. Half of all adults have one or more chronic conditions. They are triggered by risk factors such as smoking, lack of physical activity, unhealthy diet, and stress. Some say that work is the 5th leading cause of death, knowing that heart attacks go up 20% on Mondays. Millennials are in a high demand across all industries and make up 1/3 of the U.S. workforce. That number will rise to 75% over the next 7 years. So let's start there. Market studies say that wellness is a daily pursuit for the millennials. Turns out all generations care more about their health today. They are realizing that the workplace can be a part of their plan to live a better and longer life. Employees are evaluating employers on this wellness component. The most progressive companies are turning to health-focused strategies to attract and retain talent and to keep employees performing at their best. Managing employee stress and talent are the two biggest challenges facing companies today. Incorporating wellness in the workplace helps companies solve for both. It is time for wellness to come to the forefront of the conversation. We are all well versed on the importance of sustainability. The wellness conversation is taking it to the next level. The spaces that we live and work in every day have a significant impact on us as human beings. A well building is one that is designed, constructed, and maintained to improve the health, happiness, wellness, and productivity of its users through the built environment. We've relied on labels for a long time to prove that a product meets our expectations, especially when the differences aren't visually obvious, as in the case of acoustics. Labels validate compliance with rigorous guidelines and performance outcomes. The label gives us confidence that the building is acoustically healthy. The International Well Building Institute aims to do for people what LEED has done for sustainability, bringing the human-centric wellness equivalent. The elements noted here are components that the Well Building Institute has set standards for. So let's examine in more detail their sound requirements. The acoustical component of a well building begins with sound mapping. Architects label spatial plans to indicate their project includes quiet zones, loud zones, and mixed zones. The Well platform guides project teams through the development of a custom scorecard. The D platform suggests a selection of features based on project-specific parameters that can be further defined and refined by the project team. Well examines 5 areas to ensure optimized acoustics. Maximum noise level optimization. Designing with background noise level criteria in mind is key to ensuring acoustical comfort across a range of project types. When exposure to noise is reduced, occupants are less susceptible to distraction, overall stress, and potential health risk. Sound barrier optimization. Increasing privacy between spaces, especially sensitive spaces, has the potential to reduce distraction or disturbances that external noise sources may cause for occupants. Sound absorption optimization. Designing a space with reverberation time and reflected sound energy in mind can drastically improve the comfort level of occupants in terms of critical listening, speech projection, memory retention, and speech privacy. Sound masking optimization. Sound masking is an effective method that, when installed and commissioned correctly, has the potential to bolster acoustical privacy in open workplace and enclosed office environments. Impact noise management optimization. Increasing acoustical separation between floors can foster better environments for focus and productivity. It can reduce noise-related sleep disturbances and help maintain consistent, comfortable background noise levels in rooms. ASID's headquartered building in DC was designed for environmental sustainability and human health, achieved with both LEED and WELL Platinum certification. Cornell University collected and analyzed data with a clear goal of showcasing the many ways design can positively affect the health and well-being of employees. The ASID call center receives approximately 4,000 calls per month, and sound levels in the call center reduced to a quarter of what they were before LEED and WELL standards were incorporated. Not only did acoustical quality improve, but the employee satisfaction did too. They have seen absenteeism decrease by 19% and presentism by 16%. The last few slides are focused on the anticipated changes given our current crisis. What does the future of design look like with COVID-19? Areas will definitely feel more spacious as we accommodate for social distancing. Touch-free tech will extend beyond temperature devices. Automation can help reduce the number of surfaces that people touch, reducing the spread of germs. Automated doors, voice-activated elevators, motion sensors on water and soap will all be commonplace. New filtration standards, air quality measurement systems, along with state-of-the-art air purification systems, promote a healthier workplace. Landscaping features such as living walls will be utilized to organically filter air and breathe oxygen into indoor spaces. This could mean that drop ceilings could become more commonplace, as these systems can be housed and hidden above the ceiling. There will be a particular emphasis on materials that can be effectively cleaned in all markets. Healthcare ACT could be a baseline specification for not just hospitals, but in the workplace, hospitality venues, and educational facilities. Tenants will have new expectations for cleanliness within the buildings that they lease. concludes the AIA presentation. Thank you for joining us.